The next problem I'm going to work for you is number 9 from the Math 04 exam review, where the instructions say simplify the following complex fraction. So first let's just start out by looking at the numerator of this entire fraction. And the numerator has a subtraction of rational expressions, so I need to find a common denominator. Anytime we want to subtract fractions, we have to have a common denominator. The common denominator for just the numerator of this, I'm just looking up here right now, so I'm looking at the 4 and the x squared. The common denominator for that is, of course, 4x squared. And now I'm going to move down to the denominator of my complex fraction, and I'm going to look at these two denominators, because again I'm adding fractions, I need a common denominator. Common denominator down here is 2x. So now, as I work the problem, I have to look back just at the top now for a moment. My common denominator was 4x squared, so I have to figure out what I'm going to multiply this fraction by in order to use that common denominator, and that would of course be x squared. And I have to multiply by the top and the bottom. And now that denominator is 4x squared. I move over to this fraction, I look at what my denominator is, it's x squared. My common denominator is 4x squared, so I have to multiply the top and the bottom by 4, which of course gives me 4x squared in the bottom. So I'm multiplying here. Didn't leave myself much room there, did I? So I have x squared times 1, that's x squared, minus 1 times 4 is 4, over that common denominator of 4x squared. So far all I've taken care of is the numerator of this complex fraction. Now I'm going to move down to the denominator, and again I'm looking at 2 and x. I already decided that my common denominator was 2x, so I start with the first fraction's denominator, x, and I say what is missing from my common denominator that I need. That's the 2, so I multiply the top and the bottom of that fraction by 2. Why am I multiplying the top and the bottom of the fraction? Again, remember, the only thing I can multiply that doesn't change the value of my fraction is the number 1. 2 over 2 reduces to the number 1, so by multiplying by 2 over 2, I've changed it into the form I need, but I haven't changed the value of the fraction. So now I'm going to do the same thing to this one. My common denominator again, 2x, I have 2, I need x. So I multiply the top and the bottom by x. Now you can see both of my denominators are 2x, so let's draw our big fraction bar here. And now my numerator, 2 times 1 is 2, plus 1 times x is just x, over my common denominator of 2x. Wow, it still looks like we've got an awful problem. But remember, the rule here is when you are trying to divide a fraction, this is a fraction, by a fraction, what's the rule? We flip and multiply. So I'm going to write my first or top fraction there, x squared minus 4 over 4x squared. And now I'm going to multiply by the inverse, or I'm going to flip that bottom fraction. That gives me 2x over 2 plus x. Now I have a multiplication problem, and it doesn't look nearly as bad anymore. So I'm going to move up here to give us a little more space. Hopefully you can follow that. And now what we're going to try to do here is see if we can cancel anything out. So in order to be able to do that, I'm going to need to factor that numerator because it's not in factored form. Of course, that's a difference of 2 perfect squares, and a difference of 2 perfect squares multiplies, or factors to, I should say, the sum and difference of their roots. So that gives me x minus 2 times x plus 2. 4x squared is already factored, times 2x over 2 plus x. Okay, so now that everything's factored enough for me to see if I have any factors in common, I'm going to try to cancel out what I do have in common. I have an x plus 2 and a 2 plus x. They're exactly the same except for the order. This 2 divides into that 4 2 times, and that x divides into that x squared one time, so that just leaves me x. So now I look, I've got a 2 and an x, got a 2 and an x up here, but remember down here my 2 and my x are factors. That x is a term of that polynomial, and that 2 is a term of that polynomial. They're not factors. The factor is the entire x minus 2. I don't have that exactly down here, so that means there's nothing else I can cancel. I have x minus 2 over 2x, and that's my final solution. There you go.